So let me go through an example. I want to form an insoluble salt. And I want to form, let's say, I need to choose one which is insoluble. So I'm going to go with silver chloride. Okay, because silver chloride is insoluble. And I'm going to think backwards. So if I know I want to form silver chloride, on the right-hand side, I now need to think what I will want my reactants to be. Okay, so I kind of got you guys to do it the harder way to show you how it's much harder to do it from just saying two soluble salts. You'll want to think what the products are and work backwards. So if I have silver chloride, okay, that has to be one of my products. And this is going to be solid. It will form a precipitate and therefore easy to remove. What chemicals can I react to form silver chloride?
Could you do silver carbonate or something like that?
Let's have a look. Silver carbonate is going to be insoluble because it's not one of those. So the best way, when you've got silver chloride, go right. Chloride is going to be there, and silver is going to be there. Okay, now I need to work out what the anion and the cation for the chloride and that anion for the silver are going to be. Does this make sense so far? Please let me know if it doesn't.
Yep.
Yeah, Anton, is it making sense?
Yes.
Cool, Rafid?
Yeah.
Cool. So I've got the silver chloride, just to summarize. I want silver chloride as a product because I know it's going to be insoluble. I react two things together. So the anion on one of the reactants, reactant number 2, that's going to be chloride, and the cation of reactant number 1 has to be the silver, so that when they swap over, these two guys are going to join. Okay, now what silver is insoluble? Oh, sorry, what silver is soluble? What silver would definitely be soluble?
Silver nitrate.
Very good. All nitrates are soluble. Okay, so silver nitrate is a really good combo because the silver will form something which is generally insoluble. So silver nitrate, okay, and what could the chloride be? What chloride is soluble?
Sodium.
Yeah, anything but any of those. Okay, so then we try what? Let's try sodium. Okay, now the two metals switch place. Whoop whoop. So I get silver chloride, and what's my other chemical?
Sodium nitrate.
Nice, quick off the block there, Fleur. Are you a runner? So that's going to be sodium nitrate. Now, is sodium nitrate soluble?
Yeah.
Yeah, all nitrates are soluble, which is good, and all sodium salts are soluble, which is good. Okay, so by putting the sodium and the nitrate in two different chemicals at the start, when they become products, they're going to be the soluble one, and then the remaining two, these two guys, can be my insoluble one. Okay, so this is now going to be aqueous. And the benefit to all of this, you might be like, why is Mr. K going on about this in terms of acids and base chemistry? If I asked you to make a salt for me, the problem is sometimes, well, you learned the method last week, but the problem can be that you just don't know which chemical is which. And what's interesting about this one is if I have a beaker, okay, and in that beaker I've got these chemicals. So I've got chemical 1, chemical 2, and they react, okay? I can then pour these through a funnel and a piece of filter paper. And let's draw another beaker. And when they react, they're going to form precipitate, okay? And that precipitate gets left here. Yeah, so in this beaker, I also have X and I have Y. Now, of 1, 2, X and Y, what is going to end up in the filter paper?
X, right? The silver chloride.
Yeah, do you all understand that, Kelly? Do you understand that X is going to be on that filter paper?
I don't understand that.
So
That would have been.
Yeah.
Oh, wait, yeah, sorry, I understand. Sorry.
So 1 is aqueous, okay? Number 1 is aqueous. Number 2 is aqueous. Y is aqueous. So all three of those are dissolved in water. And X is a solid. Now, a confusion that students often have is that this arrow means all of 1 and 2 have gone to form X and Y. That's not necessarily the case. It can be the case if you worked out the exact amount of silver nitrate which reacts with exact amount of sodium chloride. In reality, that's quite hard. So when we react 1 and 2, there will also be, we react 1 and 2 to form X and Y. There might still be some 1 and 2 left over. Does that make sense?
Yeah.
Yeah. So 1 and 2, these two would normally react to obviously form X and Y. But there might be some 1 left over, there might be some 2 left over. Now, X in reality, as we've already established, is these dots, the precipitate that forms. Okay? And so X, because it's a solid, it's that wonderful solid. Let me get rid of this. There we go. Because it's a solid, it forms on the filter paper. Okay? So begs the question then, what is in the solution at the bottom? What manages to go through the filter paper? Because it's dissolved in water.
The Y.
The Y and any remaining 1 and 2. Okay, so yeah, that's basically it. I'm just going to try and tidy this up a bit. So if I have a beaker, okay, and I react 1, which is aqueous, plus 2, which is aqueous, these might go to form an X, which is solid, and a Y, which is aqueous. Okay, so then let me keep all the colors the same. That forms X, which is solid. And then therefore Y and any remaining 1 and 2 aqueous. Okay, hopefully that makes sense. So that's basically it. I realize you've only got 5 minutes left. So what I suggest you do is, if you go to It's Learning, I'll stop recording. Can you still see my screen?
No.
No.
Oh, I just stopped the screen, not the recording. Anyway, if you go to Teams, what am I talking about? Not Teams. If you go to It's Learning, you should see the page, and there is a PowerPoint that you can quickly go through. Okay. And the Ed puzzle. Does that make sense?